Welcome back. So after the basic mechanics on the basically on the human and animal power, let us now proceed to the basic concept regarding the human power. So we all know that before the advent of our machineries, human power was used by many agricultural operations such as planting, seeding, and harvesting. At present, in some areas where labor sufficient and mechanization is not fully emphasized, human power can relatively perform the job. As you can see on the picture at figure 3, the human pump or used human power to pump and to get water from the well. Okay, so that is the common pumping of water during those time. So it is according to Campbell 1990. While on the right side for our figure 4, the figure 4 shows that the human power was also utilized during the transportation of water. So there are 2 buckets there hung in a piece of rod carried by the human on its shoulder. So there are many agricultural operations, especially here in our country. We usually utilize human power for our agricultural operations. So during planting, as you can see, for example, for the planting of our rice, diba? The what you call the magtanim ay di biro, wherein they use human labor to plant rice one by one, rice seedlings one by one on the field. And also for harvesting, they used human power, example for picking ripe mangoes, for picking ripe tomatoes, or for harvesting livestock, picking chicken eggs, and many other agricultural operations. So even before and even today, we usually tend to utilize the human power, especially for the labor that requires low power output or job that can be done by low power output. Okay, human generally generates its power or its energy by eating food. Okay, so we usually take food in order for us to have energy, so that we can utilize that energy to perform a specific task, or to have the available power, or for us to have the capability to perform a certain job. Okay, so the chemical energy from the food that we eat is being converted to energy, and then some of which is being converted and used for doing work, and some, or the remaining energy is expended on bodily functions such as our metabolism and others. Okay, so not all the energy converted from the food we eat is we can use for useful work. Okay, but some of the energy from the food we eat is that our body use this for different functions. So according to Campbell, man develops a total power of 0.5 HP from the food he eats. However, like what I have said, only 0.1 HP is available for our useful work. Okay, again, the total power that the man develop is 0.5 HP, but 0.1 HP is only available for our useful work. Okay, so this data is based from a 35-year-old European laborer working 8 hours day and 48 hours per week. Okay, so that data of 0.5 HP and 0.1 HP available for useful work is came from the 35-year-old European laborer. So they studied the European laborer. This may vary from 20-year-old person. Of course, output can increase by 50% since maybe they are young, their body is much capable, and while 60 years old person should have an output decreased by 20%. Okay, instead of 0.1 HP, when we are talking about the older persons, their output are we might expect a decrease by their output on their performance. Okay. Also, heavy activities would make the humans get tired right away due to exerting greater amount of energy, leading to shorter productivity time. Okay, so when we tend to have heavy activities or heavy job or drudgery job or work, then of course humans get tired easily. Okay, therefore the productivity time is expected to be shortened. Okay, while lighter activities can be sustained for longer time since it requires only lesser amount of energy to do the job. Hence, the available useful work can be said to be around at only 5 to yan, around 5 to 20%. Okay, so here in figure 5, we can see the relationship between the duration of activities and the human power output. Okay, so here in table 5, you can see here the physical output activities and the duration of power output. Okay, so as you can see here, if you increase the heaviness of the physical activities done by the human, then you might expect a shorter period of power output, wherein when you lighten the physical activities, of course, the human can work at a longer period of time. So that is the graph between the duration in terms of hour of power output and the physical power output activities in terms of watts. Okay. So in table 2, it's the list of some gross power consumption for various farming activities. Yan. So once again, the unit for watts, I mean for power, is in terms of watts or maybe in terms of horsepower. But here at table 2 for human power, they use watts as the unit for power. So for planting, the human power consumption is about 200 to 30 watts. So the human exerted about 200 to 30 watts for planting, while for plowing with animal draft, 350 to 550. So as you can see here, which is more heavier in terms of agricultural activity, the plowing or the planting. Okay, so based on the power required, we tend to need more power during plowing than during planting. While for driving single axle tractor, we need 350 to 650. Driving four-wheel or two-wheel tractor, we need 150 to 350 watts. Okay. Okay. So on the next video, we will discuss the continuation of the human power, specifically the man-hour requirement, and we will also compute the number of persons required to, or how many persons are required to do this specific job, or yeah. So see you on our next video.